Hello, and welcome to today's From the Journal session, a new event type at the AAAS annual meeting, where we invite authors from recently published science family journals to discuss their work and its implications. My name is Matt Wright, and I'm the Deputy Director of the Science Press Package. Today, we will be delving into a science robotics editorial entitled Robots Are Not Immune to Bias and Injustice, published on November 18th, 2020. This editorial posits that roboticists and engineers must consider racial biases and inequities when developing any new technology to ensure that any potential benefit outweighs the risk of harm to all affected groups. Our respondent for this section, excuse me. Our respondent for this session will be Mike Lee, editor of Science Robotics. I'll now turn it over to Mike to say a few words and introduce our speakers. Mike?
Thanks, Matt. This topic is timely. Our society continues to grapple with institutional and implicit biases across the socio-political spectrum. At the same time, we're continuously developing and adopting new technologies. The authors of the editorial puts it another way. Human-human social constructs drive human-robot interactions. Robotics is first intertwined with issues surrounding inequity and racial injustices. Here to discuss the editorial today are Monroe Kennedy III, Assistant Professor of Mechanical Engineering at Stanford University and co-author of the editorial, Carlotta Berry, Professor of Electrical and Computer Engineering at the Rose Hulman Institute of Technology. They will overview some key points of the editorial and offer some further comments to extend the discussion. After their remarks, I will pose a few questions to the speakers. The speakers will also be available to take your questions in a follow-up Zoom room, hosted by the AAAS annual meeting. More information about how to access that room is provided on the annual meeting entry for this session. So, without further ado, I introduce our first speaker, Monroe Kennedy III.
Thank you very much, Mike. Happy to be here and happy to present on Robots Are Not Immune to Bias and Injustice. I want to take a moment to acknowledge my co-author, Professor Ayanna Howard, and my co-presenter, Carlotta Berry. So today I'm going to talk to you briefly about robots and bias. And to do this, I think we need to think about three main questions. What is bias, and how do we know when it's present? How does bias lead to injustice? And how does bias find its way into robotics? So the first question is really determining the presence of bias. And to do that, we really need to understand what it is. So when we think about what bias is, we have to realize that as creatures who make decisions, bias plays a role in every decision we make every single day. This can be from the type of food you want to eat to who your friends are. And so it's just present. It's based on any favor of an idea towards or against anything that you could possibly be thinking about. So the questions are, what are these biases based on? And particularly when they can become possibly negative, they might be based on a protected characteristic. Where here I'm defining a protected characteristic as someone's ethnicity, culture, age, or possibly gender. And so the question is, for these negative type of biases, we want to figure out how does one even begin to address them. And so the first step I would posit to do that is first becoming aware of that bias. So here you see an article here on my right, Diversity in AI, the Invisible Men and Women, written by Ayanna Howard and Charles Isbell. And here you see Charles playing with this software that does a good job, or tries to do a good job, of reconstructing someone's face from a blurry image. But as you can see, it clearly does not do a good job, and we have to ask why. So particularly when we think about cases when it could possibly lead to injustice, we go back to those protected characteristics, right? So what were those biases that led to decisions that led to injustice for minority groups? And then the question is, could this sort of bias that leads to injustice be intentional or unintentional? So intentional, I would say, is the case when there's awareness of the bias and you're acting on it, and that's causing harm or hurting a marginalized group. But I think more often we see unintentional bias, where it's implicit and the actions based on these biases and assumptions lead, in fact, to harm. And so the question is, how do we address these bias and injustices in others and in ourselves? So to begin thinking about this question, I want to dive a little bit into the sort of technical aspect here and really ask the question, how does bias find its way into robotics? I would propose that there are two main contributing factors to that. One is the assumptions and model priors, and the second is information accessibility. So here in this diagram you see on the right is a very simple setup of what might be, for instance, an AI model that's learning to do some sort of classification or prediction. So here on the top, the two green boxes are what goes into training that system model. And they consist of model assumptions, as well as the training data that was used to construct and train and develop that model. And so the model assumptions or the model priors play a huge role because this comes directly from the engineer. What were their thoughts to make the problem tractable for their system to solve? Did they assume, for instance, that there would be a particular amount of lighting in the room if you were doing face detection? Did they assume other things that were crucial to making their system work that might have implicitly been based on a protected characteristic? And the harder but equally important component is the information accessibility. If you think about who's in your organization or who you trained your data with, they might not truly represent all groups that might ultimately be affected by or even benefit from the technology. And so if they're not present in the training data, it doesn't take a very deep understanding of machine learning to understand that that model may not be really good at predicting cases that don't represent or are not represented in the training data itself. So two more cases we can think about here are how do we recognize cases when bias has found its way into robotics, and how can we address instances of bias in robotics that may lead to injustice? I highly recommend checking out this article by Joy Buolamwini that discusses coded bias when the robot doesn't see dark skin. She expands on some of the concepts that I mentioned just before. But particularly going back to how do we recognize when cases, when bias has found its way into robotics, I think the easiest way to approach this is recognize when services or actions of robotic systems negatively impact groups based on these protected characteristics. And a thought on how we may address these instances is twofold. One, better engineering. We need to design and implement methods that have these considerations built inside of them. And to really get there, we may even need to think about the teams that are actually building these systems. And finally, we need to think about policy on the usage of robotic systems that helps protect all groups as we develop and deploy these systems on a large scale if they have the power to impact our society.
I would now like to introduce our next speaker, Carlotta Berry.
How to address bias and injustice in robotics. So this section, we will summarize three main components: strategies for addressing bias and injustice in robotics, implementation and team considerations, Black in robotics' role in improving the robotics community, and what steps can the robotics community take to improve the landscape. So some of the strategies for addressing bias and injustice in robotics include developers must consider ethical implications of robotics usage. Educators must include ethics and societal questions in training, and teams must be diverse to provide unique perspectives and solutions. And researchers must reference the work of diverse roboticists. Here we have a picture of Jeremy Delane Brown, and he is a professor in robotics. And one way that we do this is by amplifying Black and robotics researchers. They must have a seat at the table in order to address bias. The more diverse the team is, the more likely to get those perspectives that would address some of these possible problems. So what is the role of Black in robotics? Black in robotics was created to address systemic inequities in the robotics community by focusing on the following three pillars. Black in robotics was formed during summer 2020, and the first pillar is community. And the community is about networking, mentorship, and having a social media presence. So one way to do this for networking is by all of us coming together in order to work on addressing some of these problems, as well as mentoring new roboticists in order to diversify the field more. As far as advocacy, other ways of doing this are to showcase and normalize Black excellence in robotics, connect academia and industry to diverse talent, and support and defend equity in performance and ethical use. With respect to accountability, there should be a conduit for all roboticists to participate in solutions, identify best practices, and hold each other accountable for equitable designs. So here's another picture we've taken from our social media page where we did an amplification of the engineering, the face, the robotics, the face, in order to amplify on social media more people doing work in robotics. And this is to help the community so that when people do come to us and say, we need to have a diverse member of our team, we can identify skill sets and people who can help them to make some of these more equitable designs. So what are some of our next steps in the robotics community? The first one is to continuously and always actively promote diversity in developing teams in academia as well as industry, and making those stronger connections between the two by using a conduit like Black in Robotics, and ensure that bias is considered in the research and application of robotic systems. And as I previously mentioned, one way to do this is by including more ethics training in the actual academic training of roboticists so that once they get into the field, they're also considering those components. And thirdly, make bias training and its effect in robotic applications and methods of mitigating harm a component of the curriculum so that it's integral in the research that they do. So here we have Aaron Shepard, and he is also a roboticist that works for NASA. And so he's showing a little bit of his work as well as how he can do that and also address some of these inequities.
Thank you, Professors Kennedy and Berry. I have a few questions for you. Professor Berry, you mentioned that one way of addressing bias is to create diverse teams. The editorial highlights that in 2018, 12.7% of the US population was Black or African American, but only 4.2% of bachelor's degrees in engineering went to Black scholars. Clearly, diverse teams will not form overnight. For teams where diversity is an issue, what can be done right now? And looking to the future, what can be done to create more diverse teams?
I think one key to this is for everyone to be involved in the process. For example, at Rose-Hulman, we have a program called Rosebud, which stands for Rose Building Undergraduate Diversity. And it is a scholarship program, but it's about more than just drawing students in with scholarships. It is about building community and making them feel like they're part of a network and a cohort. So in the Rosebud program, these students get very targeted mentoring and advising from the faculty. They get a peer mentor, and they also get an alumni mentor, and they participate in networking activities such as going to study sessions. They have different things about study strategies. They also have some casual time where the professors are not involved, where they go out for froyo or whatever college students like to do when professors are not around. But what we have found is by using this community building and keeping that cohort together from their freshman to their senior year, they're more likely to advance, because research has shown that women and underrepresented students typically switch out of the major, not because academically they can't do the work, but because they don't have a sense of belonging. They don't see role models, they don't see anyone who looks like them, and they don't think that they can do it. So by seeding the pipeline earlier, we will hopefully get more of them to stay and become professors in the academia, and then subsequently move on into robotics research and become part of that diverse team. But community building is the key.
Thank you, Carlotta. Professor Kennedy, you are based at Stanford University in the heart of Silicon Valley. In recent times, the approach of innovation over there has been to move fast and break things. In the editorial, you write about the importance of ethical implications of robotic usage, specifically ethical use and equity in performance. Could you explain a bit more about the process of ethical design considerations and whether such an approach can ever be compatible in Silicon Valley?
Fantastic question. Thank you. So I think that has really two parts, right? Really breaking down the ethical use and the equity and performance. For the equity and performance, right, where we want our robotic technology to work well for everyone, I think we can really draw the analogy to the autonomous vehicle industry, right? So similarly, we're moving very quickly in that space. However, if you want to deploy vehicles everywhere, perhaps if there's snow or rain and vision is poor, you have to make sure your system works everywhere before it's able to be used everywhere, right? So you don't want a vehicle that works only well in Silicon Valley to be deployed in Boston where there's snow and you could be slipping off the road. So clearly, driving in the snow needs to be a part of your problem set, needs to be a part of your information gathering, a part of the research problem, because your vehicle may possibly be used there. Likewise, when you think about any sort of technology that could definitely harm any protected group, you need to take those considerations in mind. Does it work everywhere for everyone, where it could possibly be used and have dramatic effect, both positive or negative, in people's lives? For the component of how do we actually think about ethical design, I think there are two main approaches that we can think about addressing this. One is thinking about diverse groups. So they need to be present at the table. Perhaps just having a diverse opinion in the room can help you see a component of a problem that you wouldn't have otherwise have recognized. And so that just needs to be present clearly. But then I think the harder part, right, in sort of ethical use itself, like ethical design, you can have the groups, but in ethical use, when it's deployed, right, it's kind of out of the developer's hands, right? So what can we think about in terms of that regard? Fortunately, I think the tools in AI and learning are starting to catch up, specifically in modeling uncertainty, right? If you think about generative approaches, stochastic modeling, if you can say, this is what I believe the answer is, and this is how uncertain I am, if that's truly reflective of the real world data, then perhaps that can be a component of the decision-making process. I think this is this person, but I have this wide berth of uncertainty. And if that's present beyond simple regression, your tool just became a lot safer for the end user.
And whether this approach could be suitable in Silicon Valley. What are your thoughts on that?
I'm sorry, can you repeat that one more time?
Sorry. And whether the approach of ethical design can be compatible with Silicon Valley. What are your thoughts on that?
So the compatibility with Silicon Valley, I think, with the notion of moving fast, I think that if you have the right components present in your design process, then you can definitely move quickly. I think the end result is when you deploy things, you want to make sure that you do a checklist and make sure that everything is present and accounted for before it's rolled out for end users. But moving fast, testing new technologies, I think is quintessential in developing in this space. If you look over the past 30 years at the development of computing, learning, AI, we're on an exponential increase in how all of these tools are being developed and created. So I think the answer is not to slow down, but to move strategically as we move quickly.
Great, thanks, Monroe. Okay, so to conclude, I'd like to ask each of you to provide a very brief parting thought that answers the question, what do you most hope for everyone here to take away from today's discussion? And I'll ask Carlotta to speak first, please.
Okay, so I think my parting component is about Black in robotics. And I want to state that Black in robotics was established to help address systemic equities in our robotics community. And it is based on the pillars of community, advocacy, and accountability. So that's about fostering this diversity in robotics, defending equity in performance, ethical use, and showcasing Black and underrepresented populations and their excellence in robotics, and designing pathways for the entire community to participate in the solution. So this editorial can be seen as a call to action for the entire robotics community. We all need to be aware of the issue, and if individuals need to be committed to developing solutions in their sphere of influence.
Great, thanks, Carlotta. And Monroe?
Bias and injustice can easily find their way into robotics, and we've already seen effects of this. Robotic applications should have equity in performance, meaning they work well for all groups and their performance shouldn't diminish based on protected characteristics, and ethical use, where we weigh the potential benefits against potential harm. To address this, roboticists must first be aware of their own internal biases and best practices to mitigate bias, which may possibly lead to injustice, when they're developing their robotic applications. This can be done by ensuring robotic development teams are diverse, data used to train AI models reflect all groups that may be influenced by the technology, and ethical considerations are always present in technology development.
Great, thanks, Monroe. So this has been very insightful. Thanks so much to Professors Kennedy and Berry. They will also be available in a follow-up Zoom room, as noted, and the editorial is published at the Science Robotics website online. We thank our speakers and our attendees for coming to this session of the AAAS meeting.